So hello guys. So basically, this is our project, the software side. So just as you guys can see, Lab 4, the last time any of these sources were actually updated were on the 19th. We were just waiting to see if we could get the VGA clock working, but for other reasons we really couldn't, just because of time-wise and whatnot. But anyways, going into the hardware, the first thing that we actually see, or the input module, or the first module used, is our alarm clock module. This is where the inputs are taken in and outputted to the screen. So the first thing you'll see is all our inputs, the clock in the board's clock, the keyboard inputs, what's the time format, if we want the alarm on and off, the 7-seg display, audio, and then the time of day, so like AM versus PM, and that's an LED. So we basically just have our digit holder, which is just a way of being able to tell which digit we're actually displaying on the 7-seg display. Time is basically what's the input time. The in digit holder is basically the digit holders coming from our input module from the keyboard. Time digit holders, the digits from the clock module. And basically we do this so that we can always be getting the digits that we want, or the specific digits we want from each module. And then we basically just go through in this bottom always block, and depending if we're inputting or not, affects which digits we're actually showing, if we're showing the input digit or the time digit. So then we have our 4 modules. The display module I won't be going over, this display 7-seg module I won't be going over because I've already gone over that in our previous labs. The really important ones are the time input, the clock, and the note playing. So to start off, I'm going to start off with the time input. So basically what happens is we're using our keyboard module from lab 3, if I'm not mistaken, where we basically just created a whole keyboard module that we can just reuse, change a couple of specifications to only look for specific inputs. In this case, it's A for alarm, T for time, for setting either one of those, and then your numbers 0 to 9 for inputting the time that you want. And then we have our sentence creator, which is basically just creating the sentence for the time. And basically what we do here is we're checking which number is actually being typed in. And depending on that, it limits the actual user input. So if it's the first digit, you only want 1 or 2 because you're only going to have 12 or 24. Then your second digit in your hours will be either 0 to 9 if it's 10 or 0 to 4 if it's 2. So just allowing it to be much simpler to make sure that the user can't input an incorrect value. And then for your minutes and seconds, that just goes 0 to 60. So your first digit in, or your tens digit in minutes and seconds have a max of 6, and your ones digit in minutes and seconds can go from 0 to 9. So that's basically what we did in time input, our in sentence creator and everything. And depending on if we press A or T, we basically just say what we're setting with the set value. So if it's A, we're setting 0, which is our alarm. If it's B, then we're setting 1. And then E is just for enter. So that's basically just finalizing everything, setting our input time to sentence and all that. And then this always block is just assigning the digits to the BCD values. But yeah. And then we have our actual clock, which has an input of the actual time that's coming from the time input. And we're outputting if we're enabling and TOD and all that, which I already explained. And basically what we do is when our BCD time, which is basically the time being displayed on the screen on the 7-seg display, and we're just calling it BCD because you need to represent it in BCD. We're just setting that to 24 or midnight. And then we have an alarm, and then we have our BCD in, and then we have BCD seconds, BCD minutes, and BCD hours. And basically what we're just doing there is we put it into counters, which I'll be explaining later on. But basically what we're doing there is we're just adding to it to make it easier to actually be able to add just ones to it. And we're actually using our ALU and our decoder and all that from the previous project. And the way we actually did that was by using two actual decoders. So we're using basically a front end decoder and a back end decoder. We just connected it in such a way where we didn't have to create an 8-bit number or an 8-bit decoder. We just do it 4 bits at a time. And then once you reach a maximum on one, you then do what you need to on your second. That's basically what's happening there. And then if we continue on with clock, so if CPU reset, then we just reset the time. And then on each clock's STB, which is actually coming from our clock 1 hertz seconds, which is basically really just a simple clock divider where we're dividing our 100 megahertz down to actually be 1 hertz so that we can get an actual true 1 second, which was something we were able to pull off, was actually being able to have our time actually perfectly represent 1 second. And then basically just moving forward, we just keep on adding and depending on if we reach above 60, then we just move to our seconds to minutes and minutes to hours. And then once we get to maximum 24 hours, then we go to 1. And we always keep our actual adding BCD time to 24. So it's always actually working on a 24 clock. It just makes the logic so much easier. What happens when we flip on the 12 or 24 is when we're actually displaying the number, we just subtract by 12, or we do the arithmetic that we need to do to actually display it as what it's supposed to be. And then with second adder, this is basically what we're doing, like I said before. And then the last cool thing is when we have the alarm, which is enable or not, what happens is basically when time equals the alarm, we enable the note playing. We play one note, which is, if I'm not mistaken, is the A note. And basically what we're just doing there is when the alarm plays for 5 seconds, we're basically just playing that note. Or if the user decides to set the alarm and not play the actual alarm, they can just turn off the enable, and everything else will work exactly the same way. It's just that it won't play the sound. Or even if the user wants to shut off the alarm before the 5 seconds, they can just press that and it shuts it off. But yeah, that's basically our project, or our lab for. As you can see, we did as many of the extra credits as we could, the keyboard input, the audio output for the alarm. But yeah, that's everything. So next you'll be watching the hardware implementation of everything. Thank you. So this is the hardware portion of Lab 4. So as you can see, here is the file name or the file path for the project. It's the same wagon as shown before. So now we're just going to program the device, and as here we have. So when this is down, we're in 24 mode, and we start at midnight basically. So here we have, when it's in 12-hour mode, it's 12, 00, 16, 17 seconds. And as you can see, this light right here is on. As you can see, this light right here is on, as showing as AM. So we're going to go ahead and just switch the time to 7:35-ish. I really don't know what's the seconds currently. So to do that, we come over here to the keyboard, we press T for time, and we have to input it as a 24 number. So basically, since it's 7 o'clock, that would be 19. So as you can see, I'm typing here, and then we're just going to go ahead, and now it's 36, so we're just going to type in 36 with no seconds, just for the sake of it. And then if we press enter, as you can see, now it shows it as 7:36. If we were to switch over to 24 mode, it shows it as 19:36. So if we want to set an alarm, we just press A. Again, it's in 24 input. We're the first to our hour, so 19. Let's go ahead with 37. So it's going to ring in about whatever is a couple of minutes. So if we press enter, now you can see the seconds didn't stop. It's still running. And then if we want to enable the alarm, we just press that on. So in about 20 seconds, we'll be hearing audio tune come out of the speaker here, which is the headphones, which is connected to the FPGA. So in about 5, 4, 3, 2, 1, you'll hear it. And if you just want to turn it off, you basically push it down. Otherwise, it'll play for about 5 seconds. And if you want to set the alarm and not play anything, it's basically the same thing. You just keep this module down. But yeah, that's basically how we did lab 4. We have a keyboard input. We're showing our AM, PM with this light here. You can turn on and off your alarm using this switch, or you can switch between 12-hour, 24-hour viewing here, and then we're outputting sound for our alarm there. So yeah, that's basically it. Thank you for